Good morning, good afternoon, good evening, wherever you may be. This is Luis Lopez. I'm a solutions architect specialized in Amazon Personalize. And in this webinar, we are going to go over how to offer your customers real-time recommendations using machine learning. So the agenda for today is, first we're going to start with a promise of personalization. Then we're going to do a brief introduction into Amazon Personalize. Before we transition into how to put Amazon Personalize to work through a demo I have prepared for this webinar, and then we'll jump back into the presentation to take an overview of our current customers. So before we get started with Amazon Personalize, let's take a look at how AWS think about the machine learning stack. And the way that we think about it is in a macro level, having 3 levels of the stack. So I'm going to start from the bottom level where we have the ML frameworks and the infrastructure. And this is the place where your machine learning experts are going to be hanging out. These are people who are used to building their own environment and workflows to build, train, and host models as experts. The second layer is the ML services layer. And in this layer, we have extremely simplified the workflow of machine learning. And this is a place where developers, machine learning developers, and data scientists usually hang out at by creating, hosting, and publishing models using services such as SageMaker. And then last but not least, we have our third layer, which is our AI services. And this is a perfect place for you to start your machine learning journey by leveraging services such as Amazon Personalize to augment your customer experience and business processes with machine learning. So let's take a look at what personalization offers in a business context. So the first thing that having personalization in your website offers you is the ability for your customers to discover your products and services. So for example, if you have a huge item catalog, your best bet to increase customer engagement in your website is going to be by allowing your customers to explore as many products as you can. And by providing a personalization experience, hopefully with machine learning, this allows you to do that. Once you do this, once you allow customers to explore your catalog, this will improve customer engagement by increasing your click-through rate, the watch duration of your videos, or even the dwell time on your articles. By increasing customer engagement, you will also be increasing conversion, which eventually will increase revenue for your business. Now, we have been doing personalization at Amazon.com for a long time now, and the first thing that most customers do in their personalization journey is to start writing rule-based strategy. But what we have found at Amazon is that rule-based strategies are usually effective at the beginning when your catalog is not too big. For example, you might be recommending a specific gear for particular users during Christmas time. But then when a new season comes out, then you have to go in, change the rules. And then if your catalog starts increasing, then you have to go write more rules, and then you have to maintain all those rules. So it becomes very, very hard to keep up with the customer demand, the customer intent, and it just becomes a mess quite easily. Another thing that we found is that even very rudimentary or very naive machine learning techniques perform a lot better than rule-based strategies when talking about recommendation systems. But with that said, when you're using machine learning techniques to provide personalized experiences for your customers, you start facing other types of issues. And the first ones are going to be that you will want to have a real-time recommendation system that is able to handle the 2 most common use case scenarios, which are cold start, meaning what happens when a new user comes to your website that has not interacted with your items before. How do you recommend those items to this new customer? Also, you have another cold start problem, which is recommending new items that might have joined your catalog in the middle of the day, if you're providing news or new shows that you're trying to showcase to your users. And all of these problems are complicated when you're trying to solve them using machine learning and not even think about it using rule-based. It will just take too much. The second problem that we have found is that some of these recommendation systems, ML-based or rule-based, tend to start recommending very popular items, and that starts taking away from the recommendation strategy that you're trying to provide to your users, that personalized recommendation, right? So this is a problem that we are trying to solve at Amazon.com, and we have learned from our mistakes and from our trials. Another opportunity, in this case more than a problem, is that not a single ML algorithm is a good fit for all of the personalization use cases. And we're going to see which personalization use cases Amazon Personalize helps you solve for. And last but not least is that in order to build an accurate and effective personalization model requires a lot of ML experts in order to build the ML pipeline, the data ingestion, the data processing, and hosting that real-time API endpoints for getting your recommendations. That's why we created Amazon Personalize. And Amazon Personalize allows you to create this personalization experiences using the same machine learning technology as we use at Amazon.com without any ML experience needed. So how does Amazon Personalize work? And it's, as in any machine learning-based system that you're building, it always starts with your data. In the case of Amazon Personalize, the most important data set that you're going to provide to the system, to our product, is going to be your user items interactions. And this is the data that you are most likely already collecting, all the clicks that your users are doing in your website. Maybe they're adding an item to the cart, or maybe they're watching a video, or maybe they're rating a particular product or offering. This is the data that is going to help us and you build a custom model using Amazon Personalize. The second and third data sets that you can provide to Amazon Personalize are going to be optional. The first one is going to be your inventory or your item, or as we want to call it, your item metadata, where you can provide your catalog with specific features of the catalog that you would like the model to ingest in a training time. Also, you can provide user metadata, which allows you to, again, give it a little bit more signal around your customers and your items when you're training your Amazon Personalized deployment. Once you have trained your deployment, and you can do this with 5 simple API calls, as we're going to see in the demo, you end up with a customized personalization and recommendation API where you can send the user ID and it will return the recommendations for that particular user. Let's dive a little bit deeper into how Amazon Personalize works behind the scenes. And as I mentioned before, the first thing that it does is it takes your data. As soon as you ingest your data, it is expecting a schema along that data. So it can expect it, identify the features, and then it moves into the hyperparameters. At the hyperparameters layer, if you are familiar with machine learning, or if you're interested just to run a couple experiments, there are some hyperparameters that you can tune before you trigger the training job, or you can leverage this feature called hyperparameter optimization that allows you to trigger multiple personalized model training at the same time. Of course, all of this happens behind the scene, but then at the end, you will be able to see those hyperparameters, how they were optimized, and you could take it for future deployments of your models. After your model has been trained, Personalize will host it, and then you have the option to either get online recommendations for real-time recommendations, or you can batch those recommendations and have it done at a batch level. Another really cool feature about Amazon Personalize, and it helps you solve for your user intent shifting, is the ability of having a real-time feature store. And there is this feature that is well documented in our documentation called the event tracker. So this is another thing that we solve for you, and is a completely hosted endpoint where you can start streaming your user interactions at real time while they're happening in your website. Again, this allows you to solve for your user intent. So now let's take a look at some of the use cases that Amazon Personalize helps you solve for. The first one is going to be user personalization. So as many of you have seen in multiple places, nowadays every website or most of the websites are going to tell you top list of items that they believe that you are going to interact with. And this is one of the most important use cases that you will want to think of when you're thinking about personalization, because if you have a 10,000 item catalog, how do you identify those top 10 or even top 5 items for your user? So Amazon Personalize, you can train a model that allows you to do just that based on your user interaction data set. The second use case Amazon Personalize allows you to solve for are similar items. And here's a screenshot of a item recommendation from Amazon.com where we are recommending similar rugs. So you can think of many use cases similar to this that you can implement on your website, and you can leverage Amazon Personalize to solve for this particular use case. And now the third one is personalized ranking. And explaining personalized ranking is easier through an example. And in this case, we have a screenshot of a specific category from audible.com. So now in this case, we are recommending you the top 5 items inside of the classics genre. So whenever you're needing to re-rank a list of items based on your user profile or your user interaction history, then personalized ranking is the way to go for the use case. With that said, now let's take a look at how you set up Amazon Personalize. So the first piece, as I mentioned before, is the data ingestion. So in this case, there is 2 options for you to ingest your data into Amazon Personalize. And the first one is, I want you to think about 2 types of data that you're going to be ingesting. The first one is going to be your historical interaction data. And these ones, you're going to upload them into a data set, multiple data sets. In this case, if you have multiple data sets that you're trying to upload, for example, the interactions data set, the user, and the items, and these data sets are going to come from S3. And then the second the second data type that you can ingest into Amazon Personalize are going to be your real-time events. And these are going to be ingested most likely using systems that you already have set up in place, for example, Kinesis, or maybe even a Kafka cluster. Now, once your data has been ingested into Amazon Personalize, you start training a model. You trigger a training job. And a model in Amazon Personalize, we call that a solution. And then at the solution level is where you can specify the hyperparameters and the algorithm, or in this case, we call it a recipe, to solve for one of the specific use cases I just talked about. After you have trained a solution and created a custom model behind it, you can pick between 2 options. Either you can launch a campaign, and a campaign is just a way for you to ping an API endpoint so you can get real-time recommendations, or you can do a batch inference job. And a batch inference job allows you to generate recommendations for multiple users at the same time, export that into S3, and then have other systems feed out of those recommendations. So for example, if you're running a marketing campaign for a million users, you wouldn't want to ping the campaign API a million times, but you will want to run a batch inference job of 1 million users, have the data hosted in S3, and then have your email campaign systems read from that S3 bucket to send those emails afterwards. So now let's transition into the demo. So for this webinar, I have created this demo to showcase one of the recipes. Specifically, the recipe that I'm going to be using today is going to be the HRNN metadata. And each of these recipes is mapped to a specific use case that you're trying to solve when creating your personalized experience for your website. The HRNN stands for Hierarchical Neural Network, neural nets that allow you to learn from your past user item interaction and start creating a model for recommendations. Now, no matter the use case that you have, that you're solving for, there are going to be 3 core attributes in your data that you're going to care the most about. The first one is going to be your user ID, which is the user who interacted with with the item ID, the item that was interacted with, and the timestamp, at what time the interaction occurred. In this case, I will be posting this notebook in GitHub, so I'll link it. I'll link to that. I'll link the notebook location after the webinar is done. But in this case, we're using an airline data set that includes the rating from multiple users regarding the airline. So in this case, we have an airline name, a title, an author country, a date, and multiple other columns that we could use for data set. So what we are going to do in this notebook is we're going to be using some of these columns to build the required data sets for Amazon Personalize to be trained on. So the first thing that we're doing here is we're creating a copy of the data sets themselves, and I'm going to save them in an interaction data frame and a user data frame. Now, once we have done that, now in the interactions data frame, we're going to drop most of the columns, and we're just going to keep the ones that we're interested in. In this case, we're only interested in the airline name, the author, the date, the cabin flown, and the overall rating. After some manipulation of the data, so renaming the columns and making sure the author does not have any white spaces, we end up with this particular data frame. So we have an item ID, a user ID, and a timestamp. These are the 3 core components that I mentioned before in the notebook. And now we also have an event type, in this case, which is the rating. And then we have an event value, so the rating that was given by the user based on the cabin type. So I want you to remember the cabin type, because when we are getting recommendations from our campaign, we are going to be passing in the cabin type as the context. So in this case, I will be saying, hey, which one are the best airlines that I can recommend for run based on the economy type, or based on the business class, or based on first class. So now this data set might look like it's already ready to be imported, but there are a couple considerations that you should take before you ship your data to Amazon Personalize. And the first one is going to be, are there any non-values? And if so, you will want to drop those items because it will create an import fail, and that is not what you want to see. So in this case, what I did is I was looking at the cabin type, and then I see that there is some non-items. So then that I make a mental note that I will have to drop those items. The second thing that you need to think about is the particular timestamp format. In this case, I have a format like this, but Amazon Personalize expects a Unix time format. So in this case, I have taken one particular item and I have modified it, and now I have my Unix time. So then I have wrapped all of that logic inside of this function to convert to Unix, and then I'm applying all of that transformation to my timestamp column itself. Then I am going into into my data frame to see if it has any null values. In this case, it does. So then I'm just using this function called drop none, and I am checking again if there are any null values. So now that I know that my data set, my data frame has been massaged in such a way that it can be imported into Amazon Personalize, I'm exporting it as a CSV file, and I'm just saving it as a local file in my notebook in this case. So this was my interactions data, and as you can see here, I have an item ID, a user ID, a timestamp, a cabin type, and my events. So now we're going to do something similar with my users dataset, but in this case, I'm just going to keep my user ID and the author country, and in this case, I'm assuming is their nationality, just so I can have one metadata field that my model can learn from. And then I'm exporting it as a file, again, to my local storage, so I can start uploading the data to S3. The first thing that you need to do to upload your data to S3 is you will just have to define a bucket name, and then you can use the Boto3 SDK to start uploading these files into S3. Once my files are in S3, all ready to be imported into Amazon Personalize, the first thing that I will need to do is to create a dataset group. And a dataset group allows you to have a level of abstraction, so you can have, so you can make sure that your experiments are not interfering with each other. So inside of a dataset group, you can only have one type of dataset per dataset that is accepted in Amazon Personalize. So just to make sure that everybody understands that, you can only have one interactions dataset inside of a dataset group, one user dataset, and one item dataset inside of the dataset group. So if you want to have different schemas, or you want to have different ways that you are structuring your data, you will have to create different dataset groups and then put your datasets inside of those dataset groups. So as we can see here, the APIs are very intuitive to use. It's just personalize that create dataset group. We pass in the name, and then we're saving the dataset group ARN. And what is an ARN? An ARN stands for Amazon Resource Name. So you want to make sure that you're keeping those ones saved. In this case, I'm just saving them in my notebook variables, so I can keep using them across my API calls. I am not running these cells right now because they do take some time to run, especially later on the notebook, as we're going to see pretty soon. But here's another example of where I can use my ARN, in this case, to describe the dataset group creation status. So after I have created my dataset group, the next thing to do is to define the schema of my datasets that I'm going to be uploading. So in this case, I'm defining the schema of the interactions. So let's take a look at the interactions data file that we have created earlier on. Here you go. So one thing to note when you're creating the schema is that the order that you create the schema needs to match the order that your columns in your file that you're importing into S3 are. So in this case, we have item ID, user ID, timestamp, and then we have cabin type, and I have set the categorical field to true, so I can use these for my contextual recommendations. So after I have created my schema, then I can create my data set for this particular, in this case, interactions, passing in my schema ARN that I created above. And then I will do the same thing for my users dataset. So if I look at my users, you can see that my schema matches my users dataset file, right? So then I create the schema, and then I create a dataset. So now this is a good point for me to show you how this will look in the console itself. So if I navigate to Amazon Personalize, you're going to see that the first thing that is going to show up is a pointer to your dataset groups. So let me open my dataset group. In this case, I'm working with the airlines dataset group. And then this is the same picture that I show in my presentation. So let's go into view datasets. And in this case, I already have my user dataset and my user item interaction datasets. So if I go inside of one of them, you can see here that my creates failed when I was running the tests, and this is because of the null values. So make sure you don't have any of those. And then here is also where you can look at the schema of your dataset. So it's very simple. I did all of this through the notebook itself, but you could definitely do it from the console as well. So now let's go back into the notebook and let's keep going through the cells. So after you create your datasets, the next thing to do is to set up your S3 and your S3 policies and IAM roles for Amazon Personalize to be able to import your files inside of the system, right? So the first thing that we're going to do is we are creating a personalized S3 access policy, and these ones are a little bit more open that you should have, but we're just showcasing the functionality here. The next thing to do is to create an IAM role that allows Amazon Personalize to have access to S3. In this case, we're only given S3 read-only access, so you can read the files that we created. And after that, you have your role name. So that's what you're going to pass in to your import job for your Amazon Personalized data import job. Right. So in this case, I'm pointing out to the bucket where I have uploaded my interactions data. I'm passing in the role ARN that I created that only has S3 read access. And I start triggering my import jobs for both my interactions dataset and my users dataset. So one thing to note here is that if your object in S3 is encrypted, then you will have to add that encryption permission inside of the role, so Amazon Personalize can go and decrypt that object and import it into Amazon Personalize itself. Once your job imports are active, right? In this case, this is why I'm not running the cells, because as you can see, it takes a couple minutes to import. Once they're active, the next thing to do is to create the solutions. So if we go back to our Amazon Personalize, we just finished with the upload datasets. So we created the schemas, we created the datasets, and now we're moving into the create solutions piece. So here, when you're creating a solution is when you need to decide which type of algorithm or which type of recipe you want to use, or which, in other words, which use case are you solving for when you're creating your model, right? In this case, the one that we're looking for is the HRNN metadata recipe, because this one allows you to add metadata to your user item interactions and also to your users and items. So this is the recipe that we're going to use in this example. So I'm setting up my recipe ARN to point to the AWS HRNN metadata, and I call the create solution API. Now, as you can see here, I have preform HPO set to true, and it's because I want Amazon Personalize to run experiments in the backend to auto-tune the hyperparameters so it gives me the best results. Now, this is suggested when you are experimenting, but when you're going into production or you already know which hyperparameters you want to have your solutions trained on, then I would highly suggest not having this true flag on, because it increases your training time, which also means that you're going to be spending a little bit more money on those training hours. After you create a solution, the next step is to create a solution version. So I'm just taking the solution that I created, I'm calling the create solution version API, and now I need to wait for that create to be active. And so now, as you can see here, I did this yesterday, and the create in process took a long time. So that's why I'm not running the cells. After you create a solution version, the Amazon Personalize will give you some metrics that you can use to get a feel on how the hyperparameters are affecting the performance of your model offline. And the way these metrics are calculated is very interesting, and I would highly suggest you taking some time to understand them from our documentation. But long story short, we take 90% of your data, we chop your data between a 90 and 10 split. We take 90%, we use it for training, 10% we use that for evaluation. Out of that 10% for evaluation, we take another 10%, which is what we use to compare the metrics for. And then you get a couple of them, the coverage, mean reciprocal rate, the normalized discounting community gain at K, and the precision at K. So in this case, I'm calling the get solution matrix API with my solution version ARN, and these are the metrics I got for this particular solution. Now that I have a solution trained and I can see some of the metrics, and looking at these metrics, they actually look pretty good. I'm getting a 40% coverage on my particular catalog of airlines, which makes sense because I'm actually adding the country as a place to model your data on. So that's why the metrics, that's why the coverage is not as high, like 100, because there may or may not be airlines that cover places in South America versus in Asia. So that's a brief overview on the metrics themselves. So after you have a solution version and a solution train, you can move on into creating a campaign for that solution. And a campaign is, again, a way for you to expose that model behind an API that you can call to get your recommendations from. So in this case, I'm setting up a campaign which also be with my solution version behind it with a minimum provision TPS of 2. I will suggest you start with 1. In this case, I have 2, just for testing purposes. Here is where we can finally start executing some cells. So if we look at my users data frame that I created, I have a couple of users, right? And I'm just taking a sample of 5. In this case, let me run it again. So after you've created your campaign, now we can start getting recommendations for these particular users. So before we start, let's take a look at some of the users that I have in my users data frame. So I'm going to get a random sample of 5 users. And in this case, we have a couple of users from the UK and Australia. So I have created this function that calls the get recommendations API with different contexts. So I have a context for economy, business, premium, economy, and first class. And then I also have a context of none. So if my context is none, then I'm not passing any context to the get recommendations. And if my context is something different than none, I'm passing that as cabin type. Now, in theory, this should get me the recommendations of the best airlines based on the cabin type, based on the user, right? So now what I'm going to do is I am going to get a sample of a user. And in this case, we want to look at previous tests that I have run. In this case, we have Deller from Australia, but let's get a new user. So in this case, we have Ardo from the United Kingdom, and these are the recommendations. Again, without context, we are getting these recommendations in the economy class. We get completely different recommendations, as well as across different cabin types. We should see a pattern. So for example, here we see British Airways. British Airways is still here. British Airways is still here. British Airways is 6 here. So we can see that the recommendations for this particular user do shift based on the context, but they are still around top 10. So if you were to put these recommendations in your website, you will take probably a list of top 5 and display all of them, and then the ranking that the recommendations appear from the API call do matter. So in this case, we're telling you the index 0 recommendations are the most likely to be interacted by your user based on the training that we did with your dataset. Now let's pick a different user to see what's happening. So Singapore, you can see here that now we're surfacing different airlines, right, based on the nationality, and these airlines order are shifting depending on the context that we pass into the API themselves. Now, after you have achieved that level of recommendations or personalization for your particular user, you may want to start tracking your user intent. So in this case, I have created an event tracker, and I have attached it to the same dataset group from earlier on. And I'm running an experiment saying, okay, now I want you to take an item ID, in this case an airline name, and I want you to rate that airline in the economy, for the economy class in the cabin type, with a rating of 10. So I'm saying I'm going to get a random list of airlines, and I'm going to rate them, all of them in the economy type with a 10. So saying out of these airlines that really like flying in economy, right? And so you can just, the put events call is very simple to make. Just a put events, you specify the tracking ID, your user ID, your session ID, and your event list, which is, in this case, the rating for that particular item with a value of 10 in the cabin economy. And then I'm doing the same thing. I'm getting the recommendations, but instead of getting the recommendation across multiple contexts, I am just getting, in this case, the recommendation for economy, just to showcase how the event tracker shifts the recommendations after they have rated these particular airlines with in the economy class. So let's first get a random user and let's see the recommendations. So in this case, we have a user, A. Crociani, and for the economy recommendations, we see Alitalia, Brussels Airways, Ryanair as the top 3. So now let's print the user ID again to make sure that we're using the correct one. So A. Crociani. So now let's get random 3 airlines. So in this case, we got Thai Airways, Australian, and United Airlines. And now let's send the ratings of 10 on economy class for all of these airlines, and let's see how that shifts the recommendation of the user itself. So it is going to take 15 seconds because of this sleep time right here. And you can see here how after sending Thai Airways, how my recommendations shifted. The same way with Australian Airlines, how my recommendations shifted. Sending this particular rating bumped Ryanair to first place and bumped Alitalia to 8th place. And then if I'm sending a different recommendations, now it bumps Brussels Airlines to first place, Lufthansa to second. So as you can see here, your recommendations are dynamically changing based on your user intent. In this case, by rating the airlines. And that could have been because these airlines are partners, or the historical interaction from other users showcase that these airlines have a strong correlation with United Airlines. So that's what I have prepared as a demo. So if you are interested in a more UI-friendly demo, we have this project that one of our essays has created. It's called the Retail Demo Store, that allows you to do something similar, but through a more UI-friendly way. So for example, in this case, if I wanted to add recommendations to a cart, add items to a cart, and then do a checkout, and then confirm my order. All of these events are being tracked in my event tracker. So when I go back to my featured items, I should see my footwear, in this case, being recommended first because of the way that I just purchased, quote, quote, footwear. And you can find this demo in GitHub. A quick Google search with Retail Demo Store GitHub should give you access on how to deploy this demo in your account and get started with more friendly UI experience. Now let's get back to our presentation, where we're going to explore some Amazon personalized customers. So here is a list of Amazon personalized customers that are actively using our service. One of my favorite, and we just had a blog out, is about StockX. If you're a shoe fan like I am, you're going to find this blog very interesting to see how StockX is giving shoe recommendations to their customers. Feel free to visit our website, aws.amazon.com/personalized/customers. We also have multiple ways for you to get help from us. For example, we have a lot of material, as I mentioned before, a couple demos, a couple GitHub pages. If you visit our GitHub AWS samples/Amazon personalized samples, you will be able to find the notebook that I just showcased in this demo. You can also reach out to our partner network or attend any of our workshops or training and certification pieces of content that we have out there. Thank you so much. Now I will open it up for some questions.